Hello there, and welcome. Tonight, we are not staying in the present. We are not even staying within the short span of human history. Tonight, we step out of our own time into a deeper memory, one that stretches back billions of years to the very question of how life began and whether it truly belongs only to Earth. Close your eyes for a moment. Imagine opening them again to a sky not familiar and blue, but heavy with strange gases, streaked with volcanic haze. Beneath your feet, no soil, no forests, no oceans teeming with fish, only a restless crust, cracking, reshaping, alive with fire. This was the Earth nearly 4 billion years ago, a place that looked less like home and more like a cosmic experiment. And yet, in this chaos, something remarkable stirred. Out of oceans of chemistry came biology. At least, that is one story. The other is stranger still. It suggests that the first seeds of life may not have been born here at all, that they may have arrived silently from beyond. This is the idea of panspermia, that molecules or even microorganisms may travel across the cosmos on comets, asteroids, or drifting dust, falling like hidden messengers into new worlds. If this is true, then Earth is not an isolated cradle. It is one stop in a vast chain of exchanges where life itself is the traveler. Scientists today know that the universe is rich with organic material. In 1969, the Murchison meteorite fell in Australia, and inside it, researchers found more than 70 amino acids, the building blocks of life, many of which do not exist naturally on Earth. In the tail of a comet, NASA's Stardust mission captured glycine, another amino acid essential to biology. Across interstellar clouds, telescopes detect alcohols, sugars, even precursors to nucleotides. Chemistry is everywhere, waiting for the right conditions to awaken. But chemistry is not the only mystery. Look above, into the skies of our own age, and you find stories that seem just as astonishing. Strange lights dancing above battlefields in the Second World War. Objects tracked by radar that vanish without a trace. Testimonies from pilots, from generals, from ordinary citizens, all pointing towards something we cannot easily explain. These are not merely legends. They are records, reports, sometimes even film, stitched into the fabric of modern history. Pause for a moment. Think of the scale of time. For nearly 4 billion years, Earth has carried the story of life. But for most of that time, it was silent, filled only with microbes. It is only in the last heartbeat of cosmic history that creatures like us have appeared, raising our eyes to the skies and asking, what else is out there? And more importantly, what came before us? The fragility of history is humbling. Rocks melt, oceans erase, winds grind mountains into dust. What was once alive may vanish without leaving a trace. Civilizations may rise and fall, leaving behind only whispers, fragments, puzzles we may never piece together. If life traveled across space, carried in stone and ice, its marks may be scattered, faint, and nearly invisible. Yet the possibility remains, lingering at the edges of science and imagination. The experiments of the last decades remind us how resilient life can be. Microorganisms have been found surviving in nuclear reactors, in frozen Antarctic lakes, in boiling hot springs. In 2015, Russian cosmonauts reported finding traces of microorganisms on the exterior of the International Space Station, alive after years in orbit, enduring vacuum, radiation, and extremes of temperature. If life can survive here, clinging to a steel surface hundreds of kilometers above Earth, why not elsewhere? And so the story splits into two threads, but they are woven together. One thread asks, did life begin here, or was it carried here? The other asks, are we truly alone in the skies above us, or are we still being visited? Together, they form a single narrative of curiosity, of humility, and of wonder. Take, for example, the Chicxulub impact, 66 million years ago. A rock 10 kilometers wide struck Earth with unimaginable force, ending the reign of the dinosaurs. The explosion hurled fragments of our planet into space. Imagine, hidden inside some of those rocks, hardy microbes, sealed away from radiation, drifting for millions of years before landing on another world. In this view, Earth itself became a seed, sharing its biology with the cosmos. But now, look back upward. Consider the reports of the Foo Fighters, those strange luminous orbs seen by pilots in the skies of war. They appeared not once but again and again. Sometimes they followed planes, sometimes they danced just out of reach, always unexplained and always unsettling. The observers were trained, disciplined men, yet even they could not explain what they saw. In the tension of battle, something in the sky seemed to remind humanity of mysteries far larger than our wars. These stories are not distractions. They are mirrors. Mirrors of our questions, our fears, and our hopes. When we search the skies, we do not only search for others, we search for ourselves, reflected back through light and shadow. And this is the invitation of tonight's journey, to hold both possibilities together. That the atoms of your body may once have been frozen in a comet, carried across light years, falling into an ancient ocean. And that the skies above may still hold visitors unknown, lights that remind us we have never truly been alone. As we begin, let these thoughts guide you into rest. That life may not have started here. That Earth may be part of a greater web of connection woven across the stars. And that to wonder about this is to be human. And if you wish to continue this journey with us, take a moment now. Like this video, subscribe to the channel, and share these explorations with others. Because curiosity is not just science, it is community. It is a way of seeing the universe and of seeing ourselves. Tonight, as you drift toward sleep, remember, what if life did not begin here? What if Earth was never truly alone? Take a moment to imagine time not as we usually know it, not in days or years or even centuries. Imagine instead time as an ocean, stretching outward in waves that reach into billions of years. To us, a human life may feel long. 100 years is a full span, enough for countless memories, entire generations. But against the canvas of Earth's history, it is not even a flicker. Our planet is over 4.5 billion years old. In that vast expanse, human history, everything we have ever recorded, every empire, every invention, fits inside the last tiny sliver. If the age of Earth were a single day, humanity would appear only in the final second before midnight. Civilizations, with all their power and fragility, come and go in the blink of a cosmic eye. To truly feel the scale, imagine compressing all of Earth's history into a single calendar year. Life begins in March, dinosaurs rule in December, and humans emerge in the last hours of New Year's Eve. This perspective is not just poetic, it is practical. Because time is also a force of erasure. Earth is a restless planet, constantly reshaping itself. Mountains rise and crumble, oceans advance and retreat. Continents drift, collide, and submerge. In the deep cycle of plate tectonics, seafloors are pulled back into the mantle and reborn. In this endless recycling, what was once visible becomes hidden. What was once permanent becomes temporary. Only a handful of cratons, ancient continental cores like those in Canada, Australia, or Greenland, still hold rocks old enough to whisper about the first stirrings of life. This is why the search for beginnings is so difficult. Even if life came from beyond, delivered by comets, meteors, or drifting dust, its traces would be delicate, fragile, almost impossible to preserve across such oceans of time. The first stirrings of biology may have left their marks only in molecules, in patterns too subtle to survive the violence of billions of years. Consider the evidence we do have. The oldest rocks on Earth, found in Greenland, date back nearly 8 billion years. Within them, researchers discovered tiny isotopic ratios, chemical fingerprints that may suggest the presence of life. In Australia's Pilbara region, layered structures called stromatolites, built by ancient microbial mats, preserve a record of activity from more than 4 billion years ago. These are not bones or fossils as we imagine them. They are whispers of activity, hints that something once stirred in ancient oceans. And yet, even these clues are debated. Were they truly signs of life, or simply the product of chemical reactions under extreme conditions? The debate shows just how fine the line is between geology and biology when time has stretched so far. The challenge deepens when we look to Mars. That neighbouring planet, smaller and colder, bears scars of an ancient past, valleys carved by rivers, basins that once held seas. Some meteorites from Mars, like ALH-84A1, contain structures and chemical patterns that some scientists interpret as signs of microbial life. Others remain unconvinced, pointing to simpler, non-biological explanations. And unlike Earth, Mars lacks active plate tectonics, meaning its surface can preserve features billions of years old. Paradoxically, this makes Mars a more reliable archive of early conditions than Earth itself. Think also of the Chicxulub impact again, 66 million years ago. To us, that is deep time. To Earth, it is recent. The dinosaurs thrived for nearly 180 million years, longer than mammals have existed, longer than flowers have bloomed. And yet, all it took was one rock from space to end their reign, reshaping ecosystems forever. Life is both resilient and fragile. It endures across unimaginable spans, and yet it can be overturned in an instant. Pause here. Feel the scale of this. Civilizations think of themselves as permanent. But deep time reminds us that permanence is an illusion. Erosion, subduction, volcanism, all are forces of forgetting. They erase what once was, leaving behind a clean slate upon which new stories are written. And this erasure is not only geological, it is cosmic. Radiation from space bombards surfaces, breaking molecules apart. Impacts scatter and pulverize. Even in the quiet stretches between catastrophes, the steady flow of time wears everything down. If panspermia brought life here, its evidence may be long gone, erased by the very processes that make Earth habitable. Yet in that erasure lies a paradox. Life thrives because Earth recycles itself. The tectonic churn of continents drives carbon cycles, stabilizing climate. Erosion feeds oceans with nutrients. Catastrophes clear the way for new diversity. The same forces that destroy evidence of the past also create the conditions for futures to unfold. Without recycling, Earth might have been sterile. With it, life endures, but its history is fragile. So when we ask whether life began here or elsewhere, we face a silence shaped by time itself. The rocks speak, but faintly. The molecules hint, but do not declare. And perhaps this is fitting, because the question of origins is not meant to be answered in certainty. It is meant to keep us wondering, searching, reaching. For a civilization like ours, barely a few thousand years into literacy, this scale is dizzying. We imagine permanence in buildings, monuments, and data. But these too will crumble. The future may find only fragments of who we were, or perhaps nothing at all. The Earth is patient, and it does not keep our records forever. Consider how little of human history would survive deep time. The pyramids of Giza may seem eternal, but erosion and shifting sands will one day erase them. The Great Wall of China will crumble, stone by stone, into dust. Even our digital records, encoded in silicon and magnetic patterns, will not last more than a few centuries without care. Today, some scientists and archivists experiment with storage in quartz crystals or even DNA strands, hoping to leave messages that might survive millennia. But even these, compared to the churn of billions of years, are as fragile as paper in the rain. And yet, even in this fragility, there is endurance. Fossils of trilobites, tiny marine creatures still tell their stories after 500 million years. Stromatolite reefs still stand in places like Western Australia, recording the labour of microbes from the dawn of life. Impressions of leaves remain etched in stone, carrying the shape of forests long vanished. Even in the recycling of the planet, there are pockets of preservation, little windows into the past that remind us of continuity across time. This is why scientists search so carefully for biosignatures, not expecting clarity, but hoping for patterns. A particular ratio of isotopes, a molecule preserved in crystal, a layered structure in sedimentary rock. Each is a possibility, a clue, a whisper that life may have been here or there once before. And the more we learn to listen to these whispers, the more we expand our sense of belonging in the cosmos. The Earth itself reminds us that fragility and resilience are twins. Life has survived ice ages that froze the planet nearly solid. It has endured volcanic winters and asteroid impacts. It has adapted to rising oxygen, to mass extinctions, to continents tearing apart. And through it all, it continues, not unchanged, but transformed. Always fragile, always enduring. As we move forward, hold this thought gently. Time is both creator and destroyer. And if life is fragile, its persistence across billions of years is not a given, it is a wonder. And that wonder may extend beyond this planet, woven through the cosmos in ways we are only beginning to glimpse. Like this video, subscribe to the channel, and share these explorations with others. Because together we search not just for knowledge, but for perspective, the kind that only deep time can give us. When we speak about the origin of life, there is a temptation to imagine it as a sudden spark, an almost magical event where chemistry crossed a threshold and became biology. But the story may not be so abrupt. One possibility is that the building blocks of life were never unique to Earth, that they were scattered across the cosmos, waiting for the right conditions to awaken. This idea is known as pseudopanspermia, sometimes called soft panspermia. Unlike the vision of fully formed organisms traveling through space, pseudopanspermia suggests that the essential ingredients, simple organic molecules, were already widespread in interstellar clouds, in comets and in asteroids. Earth did not create these compounds, it inherited them. To put this in context, other models exist. The primordial soup hypothesis imagines lightning striking shallow ponds, sparking chemistry in isolation. The Miller-Urey experiment of 1953 famously simulated this, producing amino acids from simple gases. But pseudopanspermia shifts the perspective. It suggests that the soup's ingredients were delivered ready-made, forged in the furnaces of stars and carried across space long before Earth cooled. Astronomers peering into the cold depths of interstellar space have found surprising complexity. Using radio telescopes, scientists have detected molecules like formaldehyde, methanol, and even amino acids drifting in vast molecular clouds where new stars and planets are born. These are not rare anomalies. They appear to be common features of star-forming regions, suggesting that the chemistry of life begins long before planets exist. One of the most striking examples came from the Murchison meteorite, which fell in Australia in 1969. Inside it, researchers found over 70 amino acids, many of which are not used in Earth life, but all of which demonstrate that the cosmos itself is a factory of organics. Some of these molecules were older than our solar system, formed in the icy depths of space and preserved for billions of years. Even more intriguing, the amino acids came in both handednesses, left and right rotating forms. Life on Earth uses almost exclusively left-handed amino acids, but the fact that both were present in Murchison shows that nature makes them readily. The mystery remains. Why did Earth life choose one hand over the other? In 2009, NASA's Stardust mission returned samples from the tail of Comet Wild 2. Among the particles was glycine, one of the 20 standard amino acids used by living organisms. This discovery confirmed what many had suspected: comets are carriers of organic material capable of delivering it to planets like Earth. Later, the European Space Agency's Rosetta mission, which orbited comet 67P Churyumov-Gerasimenko, found not only glycine but also phosphorus, a critical element for DNA and cell membranes. Instruments even suggested the presence of complex carbon chains. The way Rosetta sniffed out these compounds in the comet's halo transformed our view of comets, not as inert relics, but as couriers of chemistry. The presence of phosphorus is especially striking. Without it, the double helix of DNA cannot form, and the membranes that encase cells cannot exist. To think that comets, once dismissed as dirty snowballs, carry the ingredients of life itself is to realize that the universe may be far more generous than we ever imagined. But what does organic truly mean? The word can mislead. In chemistry, organic simply refers to molecules built around carbon. It does not imply life. A cloud of methane is organic, but it is not alive. The leap from chemistry to biology requires far more polymers, replication, metabolism. Still, the abundance of organics in space means that planets like Earth began their story already seeded with raw material. The canvas was primed before the first strokes of life were painted. Consider the early Earth. Bombarded by asteroids and comets, bathed in ultraviolet radiation, and sculpted by volcanism, it was a harsh but fertile environment. The organics that arrived from space mixed with those generated locally, perhaps in hydrothermal vents at the ocean floor or in shallow tidal pools struck by lightning. The planet was a laboratory, and the ingredients were already in place. Some researchers suggest that icy comets may have delivered not only molecules but also water itself, supplementing the oceans that already formed from volcanic outgassing. Isotopic fingerprints, the ratio of deuterium to hydrogen, have been used to compare Earth's water with that in comets and asteroids, searching for the match. Though the debate is ongoing, the possibility that part of our oceans is truly cosmic inheritance adds another layer of connection between Earth and sky. This perspective changes the way we see ourselves. Life on Earth is not an isolated miracle, but part of a continuum of chemistry stretching across galaxies. If pseudopanspermia is true, then the story of life begins not in a single ocean, but in countless clouds of dust and gas, billions of years ago, before our sun was even born. And so we are left with a humbling thought: perhaps the molecules in our cells were forged in the hearts of stars, scattered by supernovae, frozen into comets, and carried across the void, until they found a home here. If so, then every breath you take, every cell that divides, is part of a story written not only on Earth, but in the fabric of the universe itself. The search for organics beyond Earth continues. On Saturn's moon, Titan, the Cassini spacecraft revealed lakes and seas of methane and ethane alongside complex atmospheric chemistry that generates tholins, reddish organic compounds that coat its surface. Titan is a frozen world, but one that mirrors processes that may resemble the early Earth. On Enceladus, another moon of Saturn, geysers shoot plumes of water vapor mixed with organics into space, offering samples of an underground ocean. Cassini's instruments even detected salts and silica grains, suggesting hydrothermal activity at the seafloor, an environment uncannily similar to the vents where life may have first thrived on Earth. Even on Mars, NASA's Curiosity rover has detected organic molecules preserved in ancient rocks, suggesting that ancient environments on Mars once had the chemistry and the preservation pathways compatible with prebiotic processes, even if it is not direct evidence of life. Each discovery reinforces the idea that chemistry is universal, not parochial, that the cosmos is not sterile, but fertile, that the seeds of life may drift everywhere, awaiting fertile ground. And if this is so, then the question of life elsewhere becomes less if and more where. Pseudopanspermia does not solve the mystery of how life began, but it changes the starting line. It tells us that when Earth's story opened, the stage was already set. The actors may have been humble molecules and minerals, but the script was written in the stars. If this wonder moves you, take a moment to join us. Like this video, subscribe to the channel, and share it with others who search for meaning in the cosmos. Because these stories are not only science, they are a reminder that we are connected deeply to everything around us. The idea of life traveling between planets sounds like science fiction, but it is grounded in serious science. This hypothesis is known as lithopanspermia, literally life in stone. It suggests that microorganisms could hitch a ride on rocks blasted off one planet, survive the journey through space, and eventually land on another world, still alive. The process begins with impact. When a large asteroid or comet collides with a planet, the explosion is so intense that fragments of the surface are ejected into space. Some of these fragments can escape the planet's gravity entirely, becoming wandering messengers of stone. On Earth, we have discovered more than 100 meteorites that originated on Mars, identified by their trapped gas signatures that match the Martian atmosphere. These rocks are silent witnesses that material can survive violent ejection and travel across interplanetary space. But can life endure such violence? Laboratory experiments suggest that it might. Certain hardy microbes, called extremophiles, are capable of withstanding shock pressures comparable to those of an impact event. Deinococcus radiodurans, for instance, is famous for its ability to repair DNA shredded by radiation. Bacillus subtilis forms spores that resist heat, cold, and vacuum. Tardigrade's tiny water bears have survived pressures greater than those at the bottom of Earth's oceans, as well as direct exposure to the vacuum of space. These organisms provide living proof that biology has strategies to endure catastrophes that would annihilate most life. Once in space, the journey continues. Here, conditions are unforgiving. Radiation from the sun and cosmic rays bombard surfaces relentlessly. Temperatures swing between extremes, scorching sunlight on one side, freezing darkness on the other. And yet, experiments repeatedly show that life can adapt. In one study, spores of Bacillus subtilis survived nearly 6 years on the exterior of the International Space Station when shielded by thin coatings of clay or meteorite dust. The outer cells formed a sacrificial barrier, but the inner ones endured, protected by their companions. The European Space Agency's XPOS experiment, attached to the ISS, extended this testing further. Lichens, algae, and bacteria were placed in trays directly exposed to space. Many survived, and some even retained the ability to grow once returned to Earth. When shielded by thin layers of rock or simulated Martian soil, survival rates increased significantly. This resilience suggests that life does not need advanced technology to travel between worlds. It only needs patience, a protective stone, and the vast conveyor belts of celestial mechanics. The third stage is arrival. A meteorite carrying microbial stowaways must survive the fiery plunge through an atmosphere and land intact. Studies of meteorites that fell to Earth show that while their outer layers are scorched to ash, their interiors remain relatively cool, potentially protecting any life inside. Computer models indicate that even during violent re-entry, internal temperatures in large meteorites can remain below 100 degrees C well, within survivable ranges for hardy spores. In 2014, scientists analyzing the Martian meteorite Tisent concluded that organic compounds were preserved despite the pressures and heat of its journey. Taken together, these stages, ejection, transit, arrival, suggest that lithopanspermia is at least plausible. The universe, it seems, provides natural experiments. Rocks do move between worlds, and life may be hardy enough to follow. In fact, estimates suggest that trillions of kilograms of Martian rock have landed on Earth over the last 3-5 billion years. If Mars once hosted microbes, it is conceivable that some hitchhiked to Earth. Conversely, Earth's life may have seeded Mars or even Europa, Titan, or the moons of Jupiter and Saturn, carried outward by collisions in the early chaotic solar system. This idea forces us to reconsider the uniqueness of Earth. If life can spread from planet to planet, then perhaps we are part of a larger biological network, connected by stone messengers drifting silently through the solar system. Life may not simply emerge, it may migrate. Our origins may be less like a solitary spark and more like a flame passed from one torch to another. Reflect on this possibility for a moment. The story of life may not be confined to the cradle of Earth. It may be a traveller, a cosmic migrant carried by stone and time. And if so, the question is no longer whether life could exist elsewhere, but whether, in some distant way, it is already family. As you listen, let the thought linger. Somewhere in the vastness of space, fragments of rock may still be carrying ancient spores, drifting across light years, waiting to fall upon new worlds. And if that is so, then life is not Earth's alone, but the universe's gift to itself. If you are intrigued by this journey through space and stone, remember to like this video, subscribe to the channel, and stay with us as we explore the mysteries of life's resilience. If life can ride within stones ejected into space, there remains one final challenge: the return. A rock travelling through the void eventually collides with another world. For microbes hidden within, this is the most dangerous phase of all: the blazing descent through an atmosphere. As the meteorite hurtles downward, friction with the air ignites its outer layers. Temperatures soar to thousands of degrees. The surface glows, melts, and in some cases vaporizes entirely. It would seem like certain death for anything inside. And yet, appearances can be deceiving. Because while the exterior burns, the interior can remain surprisingly cool. Studies of meteorites recovered on Earth show this contrast clearly. The fusion crust, a thin blackened shell, testifies to fiery entry. But cut open a meteorite, and inside you may find minerals unaltered by heat, sometimes containing delicate structures that survived untouched. This means that any microbes protected deep within cracks or pores could, in theory, survive the inferno of re-entry unharmed. Laboratory experiments have tried to reproduce these conditions. Scientists have heated rock fragments in plasma tunnels that simulate atmospheric entry. They embedded spores of Bacillus subtilis or resilient lichens within tiny cavities. The results are fascinating. Although most surface organisms are destroyed, those shielded by even a millimetre or two of stone often endure. In some cases, microbes survive not only the heating, but also the shock of impact when the sample struck the ground at speed. In 2007, researchers at the European Space Agency ran experiments using the Photon M3 capsule. They attached microbial samples to the heat shield, testing their ability to withstand real re-entry. When the capsule returned, some organisms were still viable. Even though outer layers were incinerated, protected cells beneath survived. Nature, it seems, always finds a way to endure. The idea of life surviving re-entry is not new. Over a century ago, the Swedish scientist Svante Arrhenius proposed radiopanspermia, the notion that spores could drift between planets propelled by the pressure of light. His idea was criticized for underestimating radiation damage in space. But his boldness opened a door. Later generations extended his vision, asking, if spores can travel, can rocks protect them? Lithopanspermia built on his imagination with evidence from geology, biology, and physics. Consider also meteorites that fell to Earth carrying organic molecules. The famous Murchison meteorite, which landed in Australia in 1969, contained amino acids and other complex organics. While this does not prove living passengers, it shows that fragile chemistry can survive the fall. If molecules can, why not microbes, given the right protection? The implications ripple outward. Suddenly, The cosmos looks less like a collection of isolated islands and more like an archipelago connected by invisible ferries of stone. Each impact, each fragment, is a potential seed vessel. Earth itself may not only be a recipient, but also a donor, scattering spores of life whenever great impacts fling its crust skyward. Mars too may have shared material with Earth across eons, weaving the two planets into a hidden biological kinship. Reflect on the humility this idea demands. The Earth we know may be both cradle and courier. Cradle, because it nurtures us. Courier, because it may send pieces of itself, perhaps alive, into the darkness. In that darkness, another world may wait, unknowingly destined to share in this grand experiment. We may already be part of a larger community of worlds, exchanging seeds silently, long before we learn to send rockets into the sky. This possibility changes the way we see life. It is not merely local, not necessarily bound to a single birthplace. It is adaptable, resilient, opportunistic. It waits in stone, hides in cracks, and trusts the physics of impact and fire to deliver it somewhere new. Life, then, is not only a survivor, but also a traveller. As you listen, imagine it, tiny stowaways asleep in rock, crossing the void, surviving heat, and then awakening in a new world, ready to grow. It is less a fantasy than a scientific possibility, one that challenges our sense of uniqueness. And if this journey through fire and stone resonates with you, take a moment now to like the video, subscribe to the channel, and stay with us. Because in the next chapter, we lift our eyes from the rocks beneath our feet to the skies above our heads, where another mystery awaits. As we leave behind the stones and microbes that may have carried life between worlds, our gaze turns upward. The night sky, always mysterious, became something far stranger in the mid-20th century. During the chaos of the Second World War, stories emerged that would shape the way humanity thought about the heavens forever. Pilots began to speak of lights that did not belong to any star, flare, or weapon. They called them Foo Fighters. The term came from a comic strip character, but what the men in the skies of Europe and the Pacific described was anything but humorous. Strange glowing spheres, brilliant orbs, and flickering lights appeared alongside bombers and fighters. They darted, hovered, and weaved in ways no human aircraft could. Pilots tried to chase them. They tried to shake them off. None succeeded. These lights seemed to play, dancing through the night like intelligent companions, immune to bullets and beyond the reach of reason. What made the reports remarkable was their consistency. It was not only Allied pilots who witnessed them. German crews also filed accounts of the same phenomena. Both sides, locked in a deadly war, assumed the lights must be some secret weapon of the other. Yet when the war ended, no such devices were revealed. The mystery deepened. Here were reports, clear and detailed, from men trained to judge distance, motion, and speed with their lives on the line. And yet no explanation emerged. Military intelligence did not ignore these testimonies. Reports were collected, catalogued, and quietly analysed. The Foo Fighters became a matter of serious consideration within intelligence circles. These were not farmers seeing lights in a field. These were decorated pilots, many with thousands of hours of combat experience. Their credibility made dismissal difficult. The phenomenon also reflected the psychological landscape of the time. The 1940s skies were already filled with fear, illuminated by tracer fire, explosions, and searchlights. In that charged atmosphere, the appearance of inexplicable lights carried even more weight. Some scientists later suggested natural explanations, perhaps electrical discharges in the atmosphere, akin to ball lightning. Others argued for stress-induced visions, illusions born of fatigue and terror. And yet, the reports were too numerous, too detailed, too alike across nations and crews to vanish into psychology alone. This is why historians often mark the Foo Fighters as the birth of the modern UFO era. Strange objects in the sky are as old as human myth. But here was something different. modern witnesses, technologically skilled, documenting encounters in precise detail during a global war. The age of ancient omens gave way to the age of unidentified flying objects, grounded in testimony that could not be easily brushed aside. The Foo Fighters also hint at a deeper truth about human perception. The skies act as mirrors. In times of peace, we look upward and imagine hope, eternity, or the divine. In times of war, we project our fears, our suspicions, and our paranoia. The Foo Fighters may have been plasma, illusions, or secret technologies, or they may have been something wholly other. But in every case, they reflected back to humanity the uncertainties of its own moment. Consider for a moment the image, a lone bomber flying through the cold night, engines droning, flak bursting all around. Suddenly, luminous spheres appear, keeping pace. They do not attack. They do not flee. They simply remain, drifting with purpose, indifferent to gunfire. The pilot is left not only with fear, but with awe. For if the sky holds such mysteries in the midst of war, what might it reveal in times of peace? Some say that the Foo Fighters prepared the public mind for what was to come. Only 2 years later, in 1947, the famous sighting near Mount Rainier by Kenneth Arnold would give the world the term flying saucers. The Foo Fighters were, in a way, the prologue. The first whispers of a mystery that would expand into one of the defining enigmas of the modern era. And so, as you listen, let your imagination drift back to those nights in the 1940s. Imagine the fear, the fire, the roar of engines, and then, among it all, lights that defy explanation. They were the first messengers of a new age of mystery. Whether tricks of physics or visitors from elsewhere, they asked the same silent question: what else is out there? If this journey through history sparks your curiosity, take a moment now to like the video, subscribe to the channel, and stay with us. Because in the next chapter, the lights will multiply. We move from the war skies of Europe to the tense silence of post-war Scandinavia, where ghost rockets haunt the night. The war had ended, but the skies refused to grow quiet. Europe was barely catching its breath when, in the summer of 1946, Scandinavia became the stage for a new wave of mystery. Newspapers filled with accounts of strange streaks of light, metallic objects, and phantom projectiles cutting across the heavens. They were soon called ghost rockets. The sightings were astonishing in their number and diversity. Some witnesses described blazing streaks like meteors, but with movements that defied expectation. Others claimed they saw objects shaped like rockets or torpedoes, glinting in daylight or glowing at night. Reports came from civilians, police officers, soldiers, and pilots. By the end of the wave, more than 2,000 sightings had been logged across Sweden, Finland, and Norway. The skies above northern Europe had turned into a theatre of the unexplained. At first, the explanation seemed obvious. The Second World War had ended just a year earlier. Everyone assumed that advanced weapons were being tested somewhere. The natural suspicion fell on the Soviet Union. Rumors spread that Moscow was experimenting with captured German V-2 technology, launching missiles across the Baltic Sea. In an atmosphere thick with Cold War tension, every streak of light became a possible threat. Sweden, though neutral, launched serious investigations. Military radars tracked unidentified objects streaking across the sky, sometimes at speeds and with maneuvers that defied conventional explanation. The Swedish Defence Staff even issued confidential reports acknowledging the seriousness of the wave, though they stopped short of drawing conclusions. Behind the headlines, the bureaucracy stirred. Air defence units were instructed to file standardised reports. Civil aviation authorities circulated guidance to tower crews. Police stations set up nightlines to receive calls. Technical committees pooled expertise from meteor specialists, artillery officers, and radio engineers. Camera teams attempted long exposure photographs. Intelligence officers compared witness sketches against known silhouettes of German and Soviet rockets. A few cases correlated neatly with meteor showers, brief, incandescent trails that burned out on schedule. but many did not. They lingered, changed speed, altered course. The most famous case occurred near a lake in Finland. Witnesses swore they saw a rocket plunge into the water, throwing up a plume of spray. Soldiers rushed to the scene. Divers were dispatched. They searched the lakebed for days. Nothing was ever found. No fragments of metal. No unexploded warhead. No evidence at all. The water swallowed the mystery whole. It wasn't the only search. Similar reports came from Sweden, where civilians and the military combed forests and lakes for debris. In one incident, an object was reported to have broken apart in mid-air before plunging into Lake Kelmiev. Again, divers explored the depths. Again, nothing surfaced. These repeated failures to find wreckage became part of the puzzle. The rockets left no trace. This lack of physical evidence created a paradox. If they were Soviet missiles, why would the Soviets test them so openly over foreign countries, risking exposure? If they were meteors, why did they appear so frequently and behave so strangely, sometimes slowing, hovering, or even zigzagging? And if they were hallucinations or rumors, how could thousands of credible observers, many of them trained professionals, describe such consistent experiences? The ghost rockets refused to fit neatly into any category. Local terminology captured the mood. In Swedish, spökraketa, ghost rockets, made the phenomena sound both technological and spectral at once. Editorials debated whether fear itself was the engine. Readers' letters flooded newsrooms, sketches, timings, compass bearings, hand-drawn maps. Some included precise estimates of altitude and speed from pilots or artillery observers accustomed to ranging targets. Others described an eerie silence, objects that moved with intent but without sound, as if gliding. Historians today see the ghost rocket wave as a mirror of its time. Europe was entering the shadow of the Cold War. Fear of invasion from above was ever present. The memory of V-2 rockets raining down on London and Antwerp was still fresh. People expected danger to descend from the skies. In such a climate, even natural or ambiguous phenomena could be interpreted as weapons. Fear filled in the gaps where certainty was missing. The unknown, once again, became a canvas for human anxiety. And yet, the ghost rockets also carried elements that resist simple explanation. Some accounts spoke of objects performing maneuvers no meteor or missile could replicate. There were reports of objects that seemed to hover, then accelerate away at incredible speed. Others described projectiles that broke apart mid-air and reassembled, or that made controlled turns. These details, scattered across credible testimonies, prevent historians from dismissing the phenomenon as pure imagination. For ufologists, the ghost rockets are a crucial link between the wartime Foo Fighters and the explosion of UFO sightings that would follow in the late 1940s. They represent a transitional moment, no longer wartime illusions, not yet the flying saucers of pop culture, but something in between. They demonstrate how quickly human imagination, fear, and genuine mystery can combine into narratives that shape culture. The investigations themselves left a secondary legacy: procedure. Scandinavia's response, systematic reporting, collation of radar logs, targeted searches, prefigured the official protocols that the United States would adopt within a year. The ghost rockets were not only a mystery to be solved, they were a rehearsal for how modern states would manage the unknown in the age of radar and rockets. The ghost rockets also remind us of a deeper truth. When confronted with the unknown, humanity projects its state of mind onto the heavens. In times of war, we see enemies. In times of peace, perhaps angels or visitors. In 1946, with the Cold War dawning, the sky became the stage for missiles that never were. Whether they were natural, technological, or something else entirely, the ghost rockets carried the weight of human expectation. Picture it. Quiet northern nights broken by sudden streaks of fire, anxious communities peering upward, newspapers filled with speculation, and divers combing lakes for fragments that never existed. The silence of those empty waters still speaks today. Sometimes mystery leaves no wreckage, only questions. And if following these trails of fire into history fascinates you, take a moment to like the video, subscribe to the channel, and stay with us. Because in the next chapter, governments will no longer stay silent. They will step forward, beginning the first official investigations into the UFO mystery. By 1947, the world was only beginning to adjust to its new post-war reality. The atomic age had dawned, and the Cold War was crystallizing. Against this backdrop, a different kind of tension filled the skies. That summer, across the United States, strange reports multiplied. It began with Kenneth Arnold's famous sighting over Washington state, 9 bright objects moving like saucers skipping across water. The phrase "flying saucer" was born overnight, and the press spread it like wildfire. Within weeks, the expression was on every front page. Comic strips joked about it, preachers warned about it, and air defense officers worried about it. Soon, the reports snowballed. Farmers, policemen, airline pilots, even entire groups of soldiers filed accounts. People described flying discs and saucers darting across the heavens. Newspapers splashed them across headlines. Public fascination grew, but so did military concern. Could these objects be new Soviet weapons? Could they be a threat? For the Air Force, the time had come to act. Concern could no longer be brushed aside as fantasy. And so, in the closing months of 1947, the USS Air Force created what would become known as Project Sign. Project Sign was established at Wright-Patterson Air Force Base in Ohio, the same facility where captured German technology and aircraft were already being studied. This detail mattered. Wright-Patterson had already become a hub for reverse engineering, Nazi advances like the V-2 rocket, the jet-powered Me-26-2, and rumoured flying wing prototypes. To house UFO reports in the same environment signalled one thing: the government considered them potentially serious technology. The tasking was simple on paper, but vast in practice. To collect, evaluate, and analyse all credible UFO reports, and to determine if these phenomena represented a danger to national security. For the first time, the UFO mystery was not just gossip or newspaper sensation. It had become a matter of state, assigned to analysts, engineers, and intelligence officers who were expected to treat every case with rigour and discipline. The cases came quickly. Hundreds of reports streamed in from across the country, with more from overseas bases. Many were easily explained: weather balloons shimmering in twilight, bright planets mistaken for moving objects, aircraft reflections at unusual angles. But others defied explanation. Military pilots described metallic discs pacing their planes. Radar operators tracked high-speed objects performing impossible turns. Ground personnel swore to formations of glowing orbs passing silently above. These accounts resisted easy dismissal and added pressure on the team to look beyond conventional answers. What gave these reports weight was not just their content, but their witnesses. These were not casual observers or frightened civilians. They were professionals, trained to estimate altitude, speed, and trajectory with their lives at stake. To dismiss their testimony required more than a shrug. It required active skepticism, and sometimes selective blindness. Inside Project Sign, debate burned hotter with each month. Some analysts argued the sightings might be advanced Soviet aircraft, perhaps experimental jet prototypes reverse, engineered from German technology. Others countered that the performance described in the best reports, instant acceleration, sharp turns, silence, exceeded anything the Soviets could plausibly field in 1947. The disagreement came to a head in 1948, when the team drafted a document that would become infamous, the Estimate of the Situation. The estimate was more than a report, it was a bold assertion. After weighing the strongest cases, some officers concluded that the simplest explanation was extraordinary. The craft might not be of earthly origin at all. Extraterrestrial visitation, they argued, fit the evidence better than experimental planes or atmospheric illusions. It was a conclusion reached reluctantly, but it was reached nonetheless. The document was forwarded up the chain of command. General Hoyt Vandenberg, then Chief of Staff of the Air Force, reportedly rejected it outright. He refused to endorse such an extraordinary claim without proof, and the estimate was ordered suppressed. Copies were said to have been destroyed. For decades its existence was debated, whispered about by insiders, until testimony from multiple officers confirmed that the estimate had indeed been real and buried. Officially, Project Sign continued, but its tone shifted. Public statements grew cautious, emphasizing conventional explanations. Behind the scenes, however, the idea of visitors from elsewhere had already been raised, and once raised, it could never be completely erased from the conversation. Analysts who had dared to entertain the extraterrestrial hypothesis found themselves sidelined, while the program as a whole grew more skeptical. Historians view Project Sign as the first great paradox of the UFO age. Here was a government office quietly considering and even endorsing the possibility of extraterrestrial craft, while outwardly assuring the public that nothing was amiss. It represents the tension at the heart of the UFO story, the tug of war between curiosity and control, between science and politics, between what is seen and what is admitted. Imagine the atmosphere at Wright-Patterson in 1948, offices stacked with files, analysts bent over reports, heated arguments over coffee late into the night. Some believed they were glimpsing evidence of a cosmic reality. Others saw only threats of foreign power. Both camps knew the stakes were enormous. To admit extraterrestrial craft would reshape not only science, but society itself. To deny them might mean ignoring a genuine danger, or concealing the greatest discovery in history. Project Sign lasted only a short time before being reshaped into its successor, Project Grudge, and later Project Blue Book. But in its brief existence, it set a precedent. It showed that officialdom would not hesitate to study the unexplained, but also that when conclusions were inconvenient, they could be buried. In that sense, Project Sign still speaks today, reminding us that mysteries are not only about the unknown in the sky, but also about the choices we make on the ground. And as you reflect on this hidden chapter of history, take a moment to support the journey by liking the video and subscribing. In the next chapter, we follow the story into the era of Project Blue Book, where skepticism and dismissal became official policy. When Project Sign gave way to Project Grudge in 1949, something subtle but decisive shifted. The impulse to inquire became the habit of explaining away. Grudge reframed unidentified flying objects from a mystery worth probing into a perception problem to be managed. Reports were treated less as data points and more as public anxieties to be cooled. By 1952, with Cold War pressures mounting and civilian sightings multiplying, the Air Force reorganized the effort under a new banner, Project Blue Book. Blue Book promised method, order, and closure. It centralized intake, triage, and archiving. It offered categories and procedures. It assigned officers and consultants. On paper, it was the rational answer to a cultural riddle. In practice, it inherited a paradox, to study a phenomenon while signaling that the phenomenon did not deserve to be studied too deeply. From its first days, Blue Book lived between two mandates, one public, one private. Publicly, the tone was steadying. Press releases emphasized normal explanations, balloons, bright planets, aircraft lights, atmospheric optics. The message was reassurance. The skies were known, the guardians were vigilant, nothing unprecedented was happening. Privately, the files told a more complicated story. Not every report fit the standard boxes. Some carried corroboration, multiple witnesses, instrument traces, consistent descriptions that resisted facile dismissal. These cases were not proof of anything extraordinary, but neither were they easily erased. Roswell haunted this era like a cautionary tale. In 1947, a premature announcement of a flying disc, followed by a rapid retraction, had fractured public trust. For many citizens, the lesson was simple. Official statements could be wrong in the morning and right by afternoon, or the reverse. Blue Book inherited that skepticism. The more it leaned on generic explanations, the more it seemed to some that a curtain was being drawn rather than a light turned on. And then came the Mantell case in January 1948. Captain Thomas Mantell, pursuing a UFO over Kentucky, crashed to his death. The Air Force insisted he had likely chased the planet Venus, or perhaps a skyhook balloon. For the public, the image of a decorated pilot dying in pursuit of a saucer underscored the stakes. For Blue Book, it was both a warning and an opportunity. Investigations had to be swift, authoritative, and calming. The summer of 1952 nearly broke that balance. In Washington, D.C., over several July nights, radars at National Airport and Andrews Air Force Base tracked fast-moving objects. Fighter jets scrambled. Pilots saw lights maneuvering with intelligence. Newspapers blared. Flying saucers swarm over Capitol. Even President Truman was briefed. Blue Book struggled to contain the fallout. Official explanations leaned on temperature inversions causing false radar returns. To skeptics, this was science. To believers, a cover story. The Washington flap became a turning point. Never again could the Air Force treat UFOs as a fringe curiosity. Inside Blue Book, the people were not monolithic. Some officers wanted rigorous analysis, careful sifting of testimony, conservative but open-minded assessment of unknowns. Others regarded the program as a public relations firewall, a way to absorb reports, reduce panic, and move on. That tension is visible in the rhythm of the files. Periods of earnest inquiry alternate with stretches of reflexive dismissal. The institution breathed in curiosity and breathed out caution. The scientific consultants embodied this tension. The most famous, Dr. J. Allen Hynek, began as a skeptic. Hired to provide astronomical explanations, he became known for phrases like swamp gas that infuriated witnesses. But over the years, confronting stubborn cases, Hynek's stance shifted. By the late 1960s, he admitted publicly that UFOs deserved serious scientific study. Blue Book, ironically, had transformed its own debunker into one of the phenomenon's most vocal defenders. Numbers gave Blue Book an aura of thoroughness. More than 12,000 cases were logged over its lifespan. The vast majority were explainable. A significant minority, roughly 700, remained unknown. The category itself was unsatisfying. Unknown did not mean exotic, it meant unresolved, insufficient data, conflicting accounts, missing context. Yet even that grey label carried weight. It acknowledged that a portion of the sky, as seen through human eyes and instruments, refused to be domesticated by easy narratives. The cultural backdrop amplified the stakes. The early Cold War trained the public to expect threats from above. Radar screens were symbols of vigilance. The air was a space of strategy, secrecy, and fear. In such a climate, unidentified objects became Rorschach tests. To some, they signaled foreign technology. To others, they hinted at something non-human. Blue Book was tasked with holding the center, treating the reports seriously enough to be responsible, but not so seriously as to inflame speculation. Communication was the fulcrum. A sentence too cautious sounded evasive. A sentence too candid sounded sensational. The safest path was procedural language. Categorize, summarize, close. Over time, that language accumulated like sediment. Case numbers, brief synopses, no unusual phenomenon, probable astronomical object. Inconclusive. The archives grew thicker. The mystery did not grow thinner. In 1966, public pressure forced the Air Force to commission the University of Colorado study led by physicist Edward Condon. The so-called Condon Report, published in 1968, concluded There was nothing in UFO reports that warranted further scientific investigation. Its verdict provided the Air Force with cover. In December 1969, Blue Book was formally closed. The final statement was trifold: UFOs posed no threat to national security, the files contained no evidence of extraterrestrial vehicles, continued investigation was not warranted. Officially, the matter was settled. Unofficially, it was only beginning. The gap between lived experiences and institutional language had become a cultural fault line. Into that gap flowed books, documentaries, debates, and a persistent, restless curiosity. What remains looking back is not a verdict, but a question about how societies handle the unknown. Blue Book shows the costs of leaning too hard on closure when the data still murmur. It shows, too, the risks of unmoored speculation when rigor falters. Between denial and credulity lies the narrow road of disciplined wonder, the willingness to investigate without promising certainty and to communicate without pretending that ambiguity is failure. If this reflection resonates with you, support the journey, like the video, and subscribe. In the final block, we step back from files and case numbers to ask what all of this, panspermia's ancient roots and UFOs' modern mirrors, says about our place in a living cosmos. We have walked a long arc together, across oceans of time and through corridors of night. We began with a question that is as simple to ask as it is difficult to answer. Where does life begin? Not simply where it began for us, here, among familiar skies and seasons, but where life itself begins in the universe. If chemistry can learn to speak biology once, can it learn again and again under other suns? And if life can arise, can it also travel carried like a message inside stone, entrusted to the patience of cosmic time itself, where eons pass like heartbeats in the chest of the universe? Pseudopanspermia invited us to imagine a universe already fertile with possibility. Long before planets finished cooling, interstellar clouds carried carbon chains, precursors of sugars, amino acids, the small alphabet of a coming story. In that picture, worlds are not solitary authors. They are editors of a manuscript that drifts between stars. A young Earth did not begin with a blank page. It began with a draft, annotated by supernovae, stitched with the cold scribbles of comets, and warmed by a sun that had only just begun to burn steadily, offering both light and energy to chemistry's long experiment. Lithopanspermia asked us to widen the lens again. Impacts do not only end stories, they also carry them onward. We pictured microbes sealed in pores of stone, sleeping through radiation, insulated from heat, crossing the Black Sea not with engines but with inertia. We followed them to the moment of return, when fire chews the surface and leaves the core intact. We learned that survival is sometimes a matter of depth. A few millimeters of rock, a few minutes of darkness, a few lucky turns of orbit. If life can ride within stone, then the universe learns to mingle its biographies. It does not write one isolated autobiography per planet. It composes an anthology, fragments shared, themes repeated, variations spiraling outward. In that vision, Earth is both cradle and courier. It receives, it nurtures, it sends. We are children of a planet, but we are also inheritors of a wider archive that began before our world had a name. Then we lifted our eyes from stone to sky. We stepped into another kind of mystery, not ancient and molecular, but modern and luminous. War darkened the mid-century, and in those darkened skies pilots reported lights that moved with intent. Foo Fighters over Europe and the Pacific. Later, phantom rockets slipping over the lakes of Scandinavia. After the war, reports multiplied: disks, orbs, triangles, sudden accelerations, impossible turns, radar traces that should not be there and then were gone. The record, fragmented and partial, remains a reminder that even the best instruments can stumble before the unknown. Institutions responded, they studied, they filed, they concluded, they closed. The official record grew cautious, favoring the ordinary over the extraordinary, the known over the not yet understood. Some of that caution was wisdom, some of it was fear. Together, it left us with a puzzle, two stories unfolding at once. One story, ancient chemistry becoming biology, life perhaps traveling in stone. Another story, recent lights in the sky met by language meant to make them small. Between the two, a single thread of mystery stretches, tying the molecular origins of life to the luminous enigmas that haunt our skies. What does it mean to live between those stories? It means remembering that we are made of starlight and patience. The iron in our blood was forged in a star's heart. The calcium in our bones was baked in an ancient furnace. The oxygen we breathe was set free by ancient microbes learning to use the sun. We already carry in us the evidence that the universe can build complexity out of chaos and equilibrium out of fire. Our very bodies are proof that impossibilities given time become ordinary. And yet we also carry an ache, the ache of unanswered questions. Are we alone? Did life visit us before we were here to greet it? Do the lights that unsettle our skies belong to someone else's story, or to forces we do not yet understand? The ache itself is not a flaw. It is an engine. It drives us to aim telescopes at exoplanets and to drill into Martian rock. It drives us to analyze fragments fallen from the sky and to read, line by line, the archives of old investigations. The ache is curiosity with teeth, a restless longing that refuses to be quieted by easy answers. Listen for a moment to the two kinds of silence that surround us. There is the deep, cosmic silence that fills the spaces between stars, a silence older than any question we have learned to ask. And there is the human silence that follows a wonder, a held breath when something does not fit. We encounter both in this story. The first is the stage upon which life may be more common than we suspect. The second is the pause in which societies decide whether to learn or to look away. Humility is the bridge between them. Humility does not mean shrinking. It means knowing the scale of things and choosing wonder anyway. It means saying, we do not know yet. It means designing instruments precise enough to tell chemistry from biology and archives honest enough to admit when a report is truly unresolved. It means refusing the temptations of easy belief and easy denial. Between the two lies the discipline of attention. Perhaps the deepest gift of the panspermia story is not certainty about origins, but a new sense of kinship. If the molecules that became us traveled oceans of space before finding Earth, then we are already connected to elsewhere. We do not need visitors to be part of a larger community. We are that community, in substance, if not in speech. The same carbon that stitches us together stitches the universe. The same laws that let amino acids form in cold clouds. Let neurons tell stories by whispering in electricity, carrying thought across the fragile bridge between cells. And perhaps the deepest gift of the UFO story is not certainty about visitors, but a new sense of responsibility. If trained observers can still be surprised by the sky, then our models are not finished. If institutions can mistake ambiguity for closure, then our processes are not complete. The responsibility is to look better, to record more carefully, to share data, to build methods that welcome the unknown without worshipping it. The sky does not owe us answers, but it does offer us questions that insist on being asked, even when the answers remain just beyond reach. So what shall we do with these twin invitations? One from stone, one from light. We can make instruments and stories worthy of them. We can teach children that science begins not with certainty, but with noticing. We can remind ourselves that the universe is older than our anxieties and more generous than our fears. We can choose the slow courage of investigation over the quick comfort of dismissal. The cosmos is patient. We can learn to be too. Now, as the journey closes, let us make the climax clear. The two mysteries, origins of life and enigmas of the sky, are not separate chapters. They are one narrative, braided through time. One whispers that life is more resilient and widespread than we dared to believe. The other whispers that reality itself may be stranger than the categories we use to tame it. Together they form not an ending, but a beginning, an opening into questions vast enough to last lifetimes. Imagine now, as you rest, the path of a single grain of dust. It forms in the atmosphere of an aging star, is cast into space, joins a cloud, falls into a comet, and sleeps in ice for 1,000,000 years. The comet swings inward, the grain breaks free, it falls into a blue planet's newborn sea. Ages pass. Cells learn to replicate. Eyes learn to see. Hands learn to build telescopes and heat shields and archives. One night, those hands hold a stone fallen from the sky and ask, could life have come this way? Imagine also a different path. A pilot crosses a night sky. The radio crackles. The world below is a map of scattered lights. Ahead, something glows. It keeps pace, then veers away, then returns. The pilot does not know what to call it. He reports what he saw. A file number is assigned. Time moves on. The pilot grows old. Yet in quiet moments he remembers. The memory is not proof, but it is a thread. Stories are woven from such threads, fragile, insistent, human. Between these two images, the grain of dust and the quiet pilot, lies our position. We are the species that can pick up a meteorite and also listen to an eyewitness. We can measure isotopes and also respect the limits of perception. We can launch spacecraft and also admit that some puzzles remain. This is not a contradiction, it is our method. It is how we walk toward answers, by putting one careful step after another, even when the path ahead is dim. If you have travelled with us this far, let the questions themselves be a kind of climax, not closure. What if life did not begin here? What if we have never been entirely alone? What if the universe is not a distant emptiness but a neighbourhood, and we are only now learning the names of the streets? These are not bedtime questions. They are wake-up calls. They are invitations to curiosity that outlive us. If this journey has moved you, consider supporting it. Like the video, subscribe to the channel, and share this with someone who loves both data and wonder. You help build a small community where curiosity is safe, where attention is valued, where ideas can take the long road. And now, rest. Outside your window, the same sky that puzzled pilots and cradled comets unfolds in quiet. Somewhere, chemistry is still trying to remember the steps to life's dance. Somewhere else, a watchful eye is tracing a light that does not have a name. You do not need to solve either mystery tonight. It is enough to feel their presence. Good night. May your dreams be large and your questions patient.